How are you guys? It's Emil. Today we're going to be going over the actual performance repository that we have for our structure and compositional analyzer featurizers. So this is pretty simple. It may not be exactly apparent how to do particular things, but anyways, uh, when you have terminal open, like right over here, this is where you're going to enter all the particular lines, copy, paste. I have this all downloaded already, so I don't need to do any of this again. So you start over here, copy and paste, start over here, copy and paste, install your requirements, install what else you need to do, and then you have to run python main.py. However, the data that you have, for example, have to be exactly in this particular directory. Let's say this is our SAF CAF Performance directory that you just installed. Your features actually have to go into your data folder, and they have to be titled features.csv. So when you're making your features using SAF CAF, they all look like this. They're all a CSV. You're going to have to rename this to features.csv. And again, you can see the entry numbers, the structures, our maybe 400 features, whatever it may be. You just drop it in where it's supposed to go, which is again features.csv. And then you just run python main.py. Oh, that's the wrong one. And then when you're in the directory, you have all of it loaded. You just run python main.py. Now it's going to read your structure types, its labels, removes columns with non-values, and then it runs support vector machine, PLSDA, XGBoost, and it does it all in about 9 seconds. So let's look at our results here. And again, everything's all in outputs, SAF CAF. And then let's look at our PLSDA plot and see how it worked. So again, only 3 structure types here. And you can see a fantastic amount of segregation. Clustering's great, besides, very minor amount of outliers. And then we could actually see the performance metrics. So I briefly went over this in another video. We're at the GUI. However, you could look at the feature importance, components of each end of those, an overall analysis of how your accuracy scales up as you increase the number of components in your PLSDA system, and then a final report that actually tells you all of the fantastic things, your precision, recall, accuracy, F1 score, across your different structure types, and you can see that's pretty fantastic along the board. And the same thing for your SVM or XGBoost. And you could get your gain score, again, interpretable features. You could see packing efficiency is a number 1 feature here when it comes to your XGBoost model. And again, very similar scores along here as well. Actually, a little bit less precision for your magnesium silver arsenide system. But anyways, that's pretty much it. You could also generate features, however else you need. Any questions, please feel free to reach out, and I'll be happy to get back to you.